Hi, good morning. This is Comp 1213, Chapter 3. Today we are going to talk about the protocols in this chapter. Now, the objective of this chapter is we're going to explain the role of protocols, organization, facility, and network communication. We're also going to explain how standards, this part explain how standards are established using request for comment. I'm going to skip it for now. Later we are going to discuss it. The third part is explain how device on LAN access resource in a small to medium sized business network. Now, network protocols. Network protocols is like speech. Now, in order for you to speak with someone, what do you need? Or let me ask it in a different way. How you speak with your friends, with your family, with any human being, how you speak? Yeah. Of course, yeah. Face to face is one of the things. Yeah. Exactly. This is the way. But there is something else. There is some rules about speaking. Like, for example, when you speak with your parents, you cannot raise your voice. When you speak with someone, usually you listen to him, wait for your turn to speak. If you have a conversation with someone and both of you are speaking in very loud, at the same time, what is going to this? Can we call it conversation or this is fight? Yeah, this is fight. This is not speaking. This is not conversation. So we have some rules. Like one of the rules, when you speak to someone, you should supposed to be listen to him, then you wait for turn to speak. You nod your head, it's as a signal for understanding what he's saying. Is that right? Or acknowledging that you receive what he's. So these are the rules. Now, in any successful communication, there's supposed to be rules. The same concept is in any communication system, like computer communications, computer networks. And we don't call it rules there, we call it protocols. We have some protocols for any conversation. And these protocols that we call network protocols, this is what we are going to study in this chapter. We are going to take like a study basic concept about these protocols. Then during this course we are going to dig deeper and deeper into these protocols until we understand a lot of it. Of course, this is just introduction to network course, but in the future you will learn a lot about these protocols. Now, network protocols, it's about how the message is formatted and structured. It's like you when you speak. There is a grammar when you speak, is that right? There is a verb, noun. There is a special sequence in every language about how you should use the words. You cannot just put the words without any sequence or grammar. It's become without meaning. Now protocols do the same thing, but in different way. It is about the process which the network devices share information path with the others. Of course, as you know, the network devices, one of the job of network devices is to help in guiding the message from one location to another and select the best path for transferring the message. Now protocols do that. It is also responsible about how and when error systems are based between the devices. If there is something wrong happen, there is an error, what's going to happen? Like if we compare it to us as a human, now what will happen or what you should do when there is a fire alarm? When there is a fire alarm, what you should do? Sitting, waiting for fire, or get out of the class? Yeah, of course, run outside the class. So why we do that? Because this is protocols. We have fire protocols. When there is a fire, there is certain things that must be done. First of all, every civilian should leave the building. What about, and who's coming to the building for turning on off the fire? Yeah, firemen. They came to the building. So there's certain protocol. Everyone should do something in the case of fire. Now, also protocols is responsible for setting up and terminate data transfer session when we transfer data. So basically this is what protocols is doing, but we have a lot of protocols for a lot of things. Now there are some of the famous protocols, probably you are aware of it, or have you, of course you've been using it before. It is HTTP. You have studied HTTP in multimedia. Now HTTP is Hypertext Transfer Protocol. This protocol is responsible for transferring the web information. Any website that you open, not any website, most of the websites are using HTTP. There is also Transmission Control Protocol. Oh, let me stop in the HTTP. You have been using HTML before? Yeah, you studied HTML. Now HTML is using HTTP protocol for transfer from one device to another. This is the way that you retrieve your website, using HTTP protocol. If you notice, when you open the Internet Explorer, a new website, at the beginning of the new website there is a name HTTP, then what? www or google.com, for example. We have also one of the well-known protocols called TCP. TCP, it is Transport Protocol, Transmission Control Protocol. We have also very famous protocol called IP, Internet Protocol. This is responsible for IP addresses. And we have network access protocols. Now, protocol, there is some standardization for our protocols. Protocol come with suits, like now these days we are using TCP IP. Probably you heard about this. This is TCP IP. TCP IP, we have several protocols in TCP IP. It's not just one protocol. We have these protocols, this application protocol, we have transport protocol, transport layer protocols, and we have IP internet layer protocols, and we have the physical. Now, TCP IP, we use it now in these days in the internet. We use it in our computers, laptop, tablets, everywhere. Your mobiles is using TCP IP. Using all these protocols when we are using the internet inside any device. Now, but it wasn't like this all the time. Previously, there was some other protocols, like there was Apple Talk. There was Novel. Novel, not where this is very old protocol. It was very famous like 20 years ago. People were using this novel. Even I have the chance to work on this novel. I was working as a consultation for one of the banks, and these banks were still using novel. This was in 1999. There was a bank that was still using novel. This is the last time that I saw a novel network, in 1999. No one now is using it. It is totally different. The concept is the same, but the way that you are working with these networks are different. Anyway, Apple Talk, this is also one of the networks that has been developed by Apple. You know Apple. Your iPhones is Apple. It was not successful. Stopped. No one used it. But everyone in the world is using now this. We have also ISO. These are suites of protocols that have been developed only theoretically. No one have really implemented these protocols. Anyway, TCP IP is what we are using now these days in the world. Now, there is a very important question. When and who bring the internet first? Now, this is the story of the internet. Internet was the first packet switching network, as in today we call it internet. It was something called ARPANET. ARPANET is the Advanced Research Project Agency Network. Now, it has come to life by 1969, it was mainframe. Mainframe is that we compare it today network as, let's say, it's like a server. And there was 4 computer. Mainframe is one computer, a centralized computer, and there is a terminal, like keyboard and mouse is distributed. So the first network was, there was mainframe, and there was 4 connecting the first come as mainframe, 4 mainframe connected computers at 4 location. So it's like 4 servers, let's say, connected at 4 locations. This is in what? In 1990? 1969. Very old. Now, ARPANET was funded by US DoD, Department of Defense. And later it was used by universities and research laboratory. It was connecting civil initial development ARPANET, creating the first router also in the ARPANET interface message processor. It was not called router at that time, IMP, Internet Message Protocol. Now in 1973, Robert Kahn and Venton Cerf began to work on TCP protocol to develop next generation ARPANET. TCP was designed to replace ARPANET. Now this is when the real stuff began. Current Network Control Program, we call it. In 1978, TCP was divided into 4 protocols: TCP, IP, and IP. Later, other protocols were added. TCP IP, it's became its name, and included Telnet, FTP, DNS, and many other protocols have been added. So let's say since 1978, the network was there. Email then later start. They start to transmit email between university or within the university, within the campus. At that time, there was chat also started lately, a few years later. The first chat relay protocol. They start one type and another terminal, and the other one is receiving what they type. So it's all began there. But in 1991, they start the HTML and HTTP. HTML and HTTP. Now it's when the internet really began, when the website began. When the website is started, everything is changed. Start to change it very fast. Before that, it was just networks. Then the internet era began. Now in these days, this is the TCP IP protocol suite, how it looks like. This has become very complicated. By the way, this is not the whole image, not the whole protocol. There is a lot of protocols that is not showing here. But these are the very famous protocols now in these days. We have application layer. In the application layer, we have DNS. DNS is used for domain name service. We'll talk about it in the next chapter. We have DHCP is the famous protocol that provide IP address for your computers. We have email protocols, SMT, SMTP, POP3, IMAP, FTP, TFTP, also HTTP, all these protocols that we are using these days. HTTP, this is the one for internet. We have transport layer, we have UDP, TCP, also internet layer. These are protocols in the internet layer, and we have access network, we have some protocols. Now, open standards. What is open standards? How it's become this, the whole story? Now, let me tell you this small story. Let's say, oh, it's not a story, let's assume that you are driving in your car, you are traveling, and suddenly your car have a problem, stopped. Or you hear some noise, the heat get up in your car. Anyway, you look for a workshop to repair your car. You find a workshop. You are driving a BMW, let's say. Your car is BMW. That's nice, is that? Okay, so you stop at the workshop, and the people at the workshop, they don't speak your language. They speak different language. How you can communicate with them? And let's add something to it. They never repair BMW before. They don't know anything about BMW. It means there is a problem, is that right? Now, this is universal problem, is lack of standardization. You speak one language, another person is speaking different language. This is the problem. Now, the internet when first start, or not the internet, let's say talk about electricity. Now, electricity, when they first start, they start to generate electricity at the end of 18th centuries. The electricity at that time, let's say talk about university. Every university, which, let's say good university at that time, and want to have electricity inside the university for lighting, for experiment, whatever, they were bringing their own generator. They're bringing their own generator. And usually this generator will be in different standardization. Like it is now in these days, our electricity is what? Is AC at our house. It is AC 220 volts, is that right? And we have a specific frequency. It is 50, I think, hertz, the frequency. 60 or 50 hertz. Now, what is happening at that time, like more than 100 years ago or 150 years ago, every university had own generator. They were generating their electricity at different frequency, at different voltage. So if you have one light, you put it in one university, probably it's not going to work in another university because they have different electricity. They have different frequency and they have different voltage level. Get it? The idea? So there was no standardization. Later, they did what? They said, this is not the way that we're supposed to work. Every university in the world, every house, every manufacturer, they're supposed to use the same electricity so that we can generate electrical devices and sell it to anyone. Okay? That's why now, if you buy a lamp or light, in any house is going to work because they use the same electricity, the same standardization for electricity. Get it? Now, who's doing this standardization? There must be someone who take the effort and time to write a standardization. He said that electricity should be like 220 volt AC and with a frequency of 50 hertz. And also someone take the effort to design how the lamp should be, how the shape. Now, if you buy a lamp, you put it in this neon, this lamp here. If you buy it from anywhere, you can put it in any one. Is that right? It's going to work. Now, who took the effort to make this standardization? Have you thought about it? Yeah. Now, these authorities, as you can see here in the screen, these authority, they make open standardization. Now, till now, cars have a problem. Like, for example, if you have BMW and you have fault in the engine, it is not easy to bring Honda engine and put it in BMW car. You cannot do that. You must bring BMW engine and put it. They don't have standardization in the cars because of different reasons. Some equipment in the car, they have standardization, like tires. If you have BMW, you can bring any tire and put it in it as long as the size is the same. Maybe the same tire will work on Toyota, on Lexus, and on BMW. Now, these organizations are making the standardization on the world. How about Internet? Internet, we have something called Internet Society. Internet Society have under it another committee. This is a committee. Bunch of people are making rules about the Internet, and we have Internet Architect Board. Now, Internet Architect Board is a board of 13 persons. One of them is the representative of the Internet Engineering Task Force. This board is deciding what to make new in the Internet or what to approve. Now here Internet Engineering Task Force is like Internet Engineering Steering Group. They have something called Internet Engineering Steering Group. In this Internet Engineering Steering Group, they have so many groups. Every group is responsible for doing something. Like, for example, there is a group for routing, there is a group for security, every group is working on something. They developed new protocols, new rules, new standardization every time. They usually work with the short-term development. This task force, Internet Research Task Force, they have something called Internet Research Steering Group also. And they have also some research group. Every research group is doing something, but this is for long-term design. They are developing the internet. The internet now in these days is not the same internet a few years ago. It's not the same internet 10 years ago. It's changing. One of the famous organizations is IEEE. IEEE is very big. Probably when you go to level 4, 3, maybe doing your postgraduate, you will work and read a lot about IEEE. IEEE, they have like 38 society, 130 journal. They are big, really big. They are in most countries in the world. They doing research conferences. They are really changing, doing some stuff. One of the famous IEEE is IEEE 802.3 and 802.11. This is 0.11 for wireless. They make a standardization for wireless. That's why this is the access point, as you can see. We have on the wall. Can you see it? That one, black box. Can you see it on the wall? Now, that access point is work on my PC. My laptop now is Samsung. I have a phone. You have a phone. Someone have a tablet. Someone have iPhone tablet. Another one have a ASUS tablet. Maybe one of you have HP laptop. Every device can work with the access point. Is that right? There's no problem. Because IEEE make the specification for the wireless protocol and wireless communication. They wrote in details so that every device, every manufacturer or every vendor, when they want to manufacturing a new device, they go to IEEE standardization 802.11, read about it, see how they should make the device, and they manufacture the device that is standard. So any other device can connect to it. The same thing for Ethernet. They did the Ethernet. The switches, router, they use Ethernet. Your PC in the lab, it's use Ethernet cable. So these are the work group or study group for the developing. We have this 0.1 for higher layer protocol, 0.3 for Ethernet, 0.11 for wireless, 15 wireless personal network like Bluetooth, for example, and so on. ISO, which is stand for International Organization for Standardization. Now, International Organization for Standardization. ISO is very big. They make standardization from management to cleaning to health to computers. They do standardization for everything. If you notice, I write iOS while it is what? ISO. Have you noticed this? Yeah. Because the original word or sequence of the word is in French, so it's have different sequence. But when you translate it to the English, it's like this: iOS. but original it is ISO. Okay, so this is ISO. They did a model, a reference model. This is the they did model, and this model we call it OSI model. OSI model is a reference model for communication, but it is only on paper. No one using it. But it was a great model for making concepts model. iOS model is called Open System Interconnection. Open System Interconnection. Anyway, this is OSI. We're going to talk about the OSI. Other standardization, we have some other standardization like EIA, Electronic Industrial Alliance. Now this one is famous with electrical wiring. Connectors, and one of the famous things is the rack, like 19-inch rack. If you remember the network lab, at the back of the network lab, what do we have? We have something called rack. It's like this. فشي يشبه ثلاجة كبير, and we have some devices here in the middle. Do you remember it? At the end of the network lab, at the back. This is called rack. Now, one of the things is the rack. The rack have width of 19-inch. And any network device that you want to connect it to this rack will just put it and connect it. Usually they came with the same fit. لا أعرض ولا أقصف ولا أطول من لازم ولا أقصر من لازم. Who making this? من الجهة اللي جت فهمت شركات المصنعة إنه كيف يصير حجم الأجهزة مالتهم. EIA did it. Okay? EIA make a standardization for the size of any network device. We have Telecommunication Industry Association, TIA. This is responsible for radio equipment, radio and cellular like mobiles, voice over IP. Now this one is doing it. So your mobile is working now. Probably you noticed that if you have a mobile, this mobile can work on Omantel and Norris. You just put a SIM card and it's going to work. Is that right? How would they make this standardization? If you have Nokia, iPhone, you have whatever device, just put SIM card, is going to work in any network. It will work inside Oman, on Norris, Omantel, it will work outside Oman, everywhere. Because ATI is making this possible. Okay? We have another one, which is ITUT. Now, ITUT is probably it's famous with video compression. It's with video. When you watch video online, or even the video that you have, any video file in your computer, ATI is famous with making standardization for video. Like if you have a CD of video, you can open it in your PC, you can open it on Windows laptop, you can open it on, let's say it is a file, a small file, video file. If you send it using WhatsApp to your friends, they're going to open it. Is that right? With different application. Everyone is using different application for watching video. And it is open. If you send it to your PC, you can watch it. Who's making this standardization? ITUT make it. Also, they are famous with broadband communication like DSL. DSL is the internet to your house. It's using DSL. Now, Internet Corporation for assigning name and numbers, ICANN. This is from the name. It is responsible for allocating IP address, allocating DNS port number. So IP, DNS, port. Sorry, it's not, yeah, port number. And INA is also for IP address allocation, domain name management, and protocol identification for ICANN. So these both are related together. So these are the famous organization. Now we have a concept of layers. In network we have something called layers. Layers, let me give you let's go back to the BMW that you have. Let's say again you have BMW. You brought this BMW 1 year ago. It was brand new. After using this BMW for traveling to foreign countries, what you had? You need to replace tires. The tires become old. What you do? Change the tires only. Is that right? Do you have to change the whole car? Of course, if you have a lot of money, you can. But do you have? No, just change the tires. Now, how possible to just change a tire? Because it is layers. The car is like layers. We have layers. We have tire layer. If there is a problem with the tires, we don't change the whole car. We just change what? Tires. It's very simple. Now here in the networks, we have the same concept. We have concept of layers. The concept of layers is every layers have some protocols. If you want to change or update some protocol, you don't change everything in your computer. You change only the specific layer. Like for example, let's say this is your laptop. Okay? And the layers here, as you can see, it is inside your laptop. Some of the layers, these layers are software. It is like a program inside your computer. These layers here are what? Hardware. So, this is your laptop. You are connected to the internet using wire. So are using this layer here. Then you go out and you decide to use wireless. Then what you're going to change here? You're going to change only this. Remove this and bring a new one, which is designed for wireless. Get it? So whatever is happening here, it is not stopped, not changed. Not even have any clue what is happening. The change is happening only what? In this layer. It's like changing tires. Okay? So let's say the benefits. There are some benefits for the layers. One of them is assist in the protocol design. There's another benefit, is assist in protocol design. So specific layer have defined information, and if you want to update protocol or develop a new protocol, you just work with the specific layer. You don't affect everything. It's have another benefit. It is easier for vendor to work together with the layers. Because let's say again we're talking about wireless, so the wireless vendor will work only on this layer, will focus on this layer. He don't need to design the whole stack, the whole protocol, change every protocol. No, the vendor will work only here. It is much more easier for the vendor to work on the one layer. And also prevent technology or capability change in one layer from affecting the other layer above and below. If you have any problem or any change, the technology change in the transport layer, it's affecting only this one. All the program and application in the layer above and below is going to stay the same. And also, finally, it's provide common language to describe the network functions and capabilities. Now, this is OSI reference model. Now, look back, to this page. What I want you to do, listen carefully. I want you to memorize this. I know I told you that my course is not about memorization. It's about understanding. Yes, this is true, but this is exception. I want you to memorize this like you memorize your name. تحفظوها مثل ما تحفظون اسمكم. Get it? In every details, very accurate. I want this image to be inside your head. Because this is very important for the future work in our chapters. Now, OSI reference model. What is OSI reference model? As we talked previously, OSI, they make some layers, but it is all theoretical layers. No one is really using it. What we are using these days is TCP IP. Now, TCP IP, they make a model, and every layer is responsible for doing something. Again, these layers, as I mentioned before, it is inside your PC or computer or laptop or phone. The first layer, 3 layers are software, and the last one is what? Hardware, yes. Now, what the application layer is doing? It represents the data to the user, plus encoding and dialog control. What does it mean? It means when you open a website, you write the name of the website, and suddenly let's say you're typing facebook.com. What you see? You see Facebook, is that right? Do you see it as 01000100 like this? Or you see it code maybe? No, you see it text, clear text, and photos, is that right? This is what you see. Now, the way that the data is representing for you, this is an application layer. Application layer is doing this. It's also responsible for encoding dialog control and making sure that the information are transferred from the Facebook server to your PC in sequence and all together. You can see it in the screen. Now, this is the application was doing. The reality, the data is not sending as a picture. They're sending as binary, 0, 1, 0, 0, 0, all these together. But this layer is responsible for making sure that you receive it and receive it in the correct application. Now, transport layer is support communication between devices across the network. This is what do is make sure that each application is receiving its own data. Make sure the data is, when you send, for example, when you send a request to facebook.com, please facebook.com bring me my website. Let's say this is your PC and this is server of Facebook. And this is the internet. When you send a message from your PC to Facebook, your message arrived to the Facebook. The transport layer is making sure that your message is arrived. And make sure to receive acknowledge from Facebook telling it that the message has been received. Now this is the transport layer what is doing. We have internet layer. Internet layer determine the best path through the network. As you remember, this is your PC, or again, this is your PC. Let's say this is your PC, and you are connected to the network router. Your router probably is connected to other routers. This is the internet. There is a lot of connections, is that right? We mentioned that in the previous chapter. Now your data have different routes. It can go this way or this way. This way or probably this way, is that right? Which way is the right way? Now who deciding this? Internet layer is responsible for this. Internet layer is determine the best path through the network. Now, network access is control the hardware device and media making up your network. Now, it's controlling the way that you're connected to the network. Like for example, this laptop can connect wireless, and I can use wire Ethernet. I have two ways that I can connect. Who's doing that? Yeah, network access. Network access actually it is two layers. It is data link and physical. Let me write. Data and physical. So this is access, network access. Now this is if we compare the OSI and TCP IP. As you can see, the first three layers in the OSI model are equivalent to what? To the application. It means application layer in the OSI and the TCP IP is doing the job for these three layers. Transport and transport, they are the same name and the same functionality. Network and internet also they are the same functionality, but the name is different. Here we call it network and here we call it what? Internet. Network access here is equivalent to these two. Data link and physical. You need to be able to compare between these layers. Now, element of communication. Now, let me ask you a question. We as a human, this is a human being. Now, let him, okay? This is a human being. Is talking with another one. They are speaking. Why we speak? Why we as a human speak? What is the philosophy behind the speaking? If we talk about speaking, let's go deeper about speaking. Why we need to speak? Yeah, it is ideas. It's mean. Tell you like this. If this person here was traveling or driving his BMW again, Okay, and he saw car accident in the road. He saw it. Step by step, what's happening? There is one was fasting, another one suddenly entered the road. The first one tried to make a break. His car was spinning, start to spinning, and then he hit the car from behind. The other car started spinning again, and the car is across the road. Anyway, describing, he saw car accident. He saw it in his eye. So he have the image of the car accident where? Inside his head. It is here inside his head. He saw it by his eyes. Then what? It is inside where? It is the car. Now it is the image inside his brain. Now he went back home and he want to tell the story to his brother. Now this is the image of the car accident. It is inside his head. He want to tell it to what? He want to move this image from, not moving actually, make a copy of this image from his head to this person's head. What he's going to do? Yeah, he's going to speak. Is that right? He's going to speak. He's going to describe it. He's going to say, I was driving home. It was sunny day. The road was very clear. Suddenly there was someone is fasting, driving very fast. Another one entered the road. He described the accident step by step, word by word. After describing in detail what is going to happen, the image of the car accident is going to be what? It's going to be here in this person's head. He will be able to what? To imagine it. When someone is telling you something, what you do? You're not just listening to the word. Your brain is trying to generate image about it. You try to imagine it. Another example, you went to the beach. It was sunny day. It was very quiet. There was some birds singing. There was a beautiful, beautiful ocean. It was the sea was very blue. The sun was white. You want to describe this. You were drinking some orange juice. You want to describe this image. It is inside your head. You can see that the sun is rising or the sun set. It is image inside your head and you want to move it to someone else. You speak. That's why people speak. It is because they have some ID inside their head or whatever they will have. Image, ID, sound. They want to transfer it to other people. So this is all about speaking. Now in these days, if you in the road and saw the car accident, you want to show it to your friends, what do? You take your mobile, take a picture, and send it. Is that right? Is it better? Yeah, it's always better. You can, or you can send them video footage. If you were making video recording at the moment of the car accident, you're not going to describe it, you just send the video. How about again, you are on the beach, you see the sunrise. This was very beautiful color in the sky. What do? Take your mobile, take a picture and send it. Is it better? Yeah. It's better than describe it. So this is the communication system. If you compare any communication system, what do we have? We have message source, it could be image inside your head. What you do? You make encoding. You try, let's say, this is the image of the sun rise. This is sun rising on the ocean. This is inside your head. You saw it. You want to encoding it. Encoding is like you making a speech, words. Then you transfer it through your mouth. To what? To the ear of the other person. This is ear, and he have a ring. The other person hear the speech, the words, make encoding until he get what? The picture inside his head. Is that right? Computers do the same. This is one computer. You have image in one computer or in one mobile and you want to send it to another mobile. What you do? You have the message. You have the message. You encode the message. Do not leave it as a picture. You make it 01000, like binary, for example, JPEG, whatever the code. This is encoding. Then you transmit it. You transmit this message. Transmit it through media. Could be wireless, Bluetooth, cellular, whatever. Then other one receive it. Encoding. Make encoding. And then the message destination on the other device. It's like sending one image from one PC to another PC. These are the elements of communication. Now, communicating the messages. Now, messages are sent from one computer to another, from one PC to a server. This is not like, for example, we have again image in this PC of the sunset, sunrise, whatever. You want to post it on Facebook, and this is Facebook. Now, this is large image. You make it a data. Your computer is going to make the data. Then your computer is doing what? It's going to divide it into pieces. These pieces called what? Segment. Segments. Now, segments is the process of segmentation, breaking communication into pieces, and then send it one by one. So it is arrive to the server one by one. The Facebook server was going to do is going to take these segments, combine it again into one message, then see the picture and post it on the website. And we have the image on the website, or the image we have it in the Facebook server. Okay, so we are segmenting, is dividing the message into small pieces and send it. There is some benefit of segmenting a message. Different conversation can be interleaved and increase reliability of communication. Of course, sending small pieces is much more better than sending one big piece. There is some disadvantages. It is increase the complexity. It is extra job by dividing the message and then combining the message into one big message. We have a protocol data unit. What is protocol data unit encapsulation? Let me draw it for you, it's better. Look at it. Let's say we have this PC. You want to send image. You have some sunset image. This is sunset image. You want to send it to what? To a server. Let's say this is Facebook. And this is your PC. Now every PC, as you remember, have something called IP address. This PC IP address 192.168.1.1. This Facebook server is 8.1.1.1, let's say. And every PC have something else called MAC address or physical address. MAC could be like, for example, A. This is MAC address, and this is IP, by the way. This is IP, and also let's have MAC. Let's say the MAC, make it something simple. Okay, this is the MAC address 1111111. Now, as we said, every PC have layers. In this case, I'm going to draw the layers. What the layers that we have? This is TCP model. We have what? Application. We have what? Transport. Internet. And network access. Now this PC is connected to this server. Don't make it Facebook, sorry. I make it something simple. Let's say this is not Facebook. This is just a normal server. Local server. It is local server or file server. File server. And you want to send this image to the file server. Now what's happening? This is the image. The image is going to treat it as data. I'm going to refer it as D. This is data at this point. Now probably it's going to be divided into pieces of data. This is D, D, D. Then what will happen? One of the piece of data is going to move down to the transport layer. So it's become, this is the data from the application layer. Transport layer, what the transport layer is going to do with it? Transport layer job is to make sure that the data arrives to the server, to the correct application to the server also, not just to the server. So the transport layer will take this message and add something to this message. It's called header. Header is like extra, we call it TCP header. TCP or transport layer header. This is in red, is transport layer header. Now in the transport layer header there is some information. We will call it port number. It will add something called source port number and destination port number. Let's say we are using HTTP protocol. Now port number is what? For every protocol, like HTTP had a port number of 80. DNS have a port number of 53. FTP have port number of 21, and so on. Why we have a specific number for every port? Because when the data arrives to the server at the end, the server will receive it. He must know that this data belongs to which application. So the server needs to know what is the port number. Okay? So let's say it is HTTP. So the destination port number will be equal to what? 80. And the source is any random number. Let's say 511111 something. Any random number. So here, if we want to make it clear, we'll add source port and destination port. This one is 80 and this one is 51111. Okay? Let me clear this. Then what will happen later? After we add TCP header, is going to move down. At this point, the TCP and the data all together called segment. It's called segment. Here it's called what? Data. In the application layer it was called data. Data plus TCP header called what? Segment. Okay? So this is data and this is segment. Then it's moved down. We still have TCP. We have original data. Then the internet layer will add something new called IP header. Sorry. IP. We'll add something called IP header. Now what the IP header? IP header is contain very important information, which is source IP address and destination IP address. We said the destination in this case is 192.168.1.2. Okay, so it's about source IP address and destination IP address. Source sorry. Something wrong happened. Yes, so we have source IP address and destination IP address. What the source IP address? Source IP address and destination IP address. What will be the source IP address in this case? We are sending from this PC to this server. What will be the source IP address? This is the source IP address. 192. I'm going to highlight it. This is the source IP address. And what is the destination? This is the destination IP address. So, as you know, every device is supposed to have address. So we need to have the source IP address in the message, and like you write when you write a message من تكتبون رسالة مثلا بالبريد ايش لازم تحطون بالرسالة؟ لا IP address بالرسالة بالبريد؟ no عنوان. Is that right? عنوان المرسل والمرسل إليه. So it's the same here. You put the IP address of the source and destination IP address. Source IP address will be what? 192.168.1.1. What about destination? 192. 168.1.2. That's okay. So I'm going to just delete this because it is too big. So we have source IP address and we have what? Destination IP. Get it? Then what will happen? Now at this point we call this what? We call it packet. All this together. Data, TCP IP header, all together called what? Packet. Now they move down to the Ethernet header or data link. We still have IP. We have we have TCP. We have data. All this together. Then we add something new to it. Frame header and the frame trail. This is a frame. We call it, at this point, we call it frame. This is a frame at this point. Now in the frame, what do we have here? We have two very important pieces of information. MAC, source, and MAC, destination. What is the MAC source in this case? Where's the MAC source? Yes, A. This is the MAC source. This is the MAC address of the first PC. What's the MAC destination? Yes, this is the MAC destination. So, in this case, MAC source is A, and MAC destination. Okay? At this point, we call it a frame. Then what will happen to the frame? What's going to happen to the frame? I'm going to show you something interesting is going to happen to the frame. Now, this is all happen where? This is all inside what? The PC. This is all happen inside the PC. We're still inside the PC. After that, encoding part. Encoding is doing what? The whole this frame, which is data from TCP, IP, and frame header, frame tail, all together will be converted into 01110001111100 and so on, and it will travel to what? To the server, to the file server, through the network. Then the file server will do what? Will do decoding. Sorry, this is encapsulation. The process here that we did, هذه process called what? Encapsulation. هذه encapsulation. Then the server do what? Will do de-encapsulation. Encapsulation that we did here is originally we had what? Only data, is that right? Originally it was only data. Then the data we encapsulate it in the TCP header. Then we add IP header. Then we add the frame, is that right? And send it to the network. Then the file server receive it. The file server will do the same thing. The network layer inside the file server, the network access layer inside the file server will do what? Will check the frame. Will check the source and destination MAC address. If it is correct, then it's going to move. Then it's going to delete the frame and send it to what? Send it to the upper layer. The upper layer will do what? Yeah, the upper layer check the IP, source and destination. If it is the same, then he will do what? Remove the IP header and do what? Send it up. The transport layer will do what? Check the source and destination, then remove the TCP header and send it what? Up until it reaches application. This is the process. It's a little bit complicated, but you're going to understand this step by step. Now let's go back. So this is the process of protocol that we just explained. This is how we do encapsulation. The same that we just speak. De-encapsulation is the opposite. Now, network layers and data link address. Now, look at here. The upper layers are responsible for encoding application data. The transport layer is doing what? Port number, source and destination, port number. It is responsible for port numbers, source and destination port numbers. Network is responsible for what? Source and destination logical address, which is IP. Here it is port. And here is what? MAC in the data link. Now look at this. This is a message. It's sent from PC1. This is PC1. This is PC1. It's sent from PC1 to what? File server. Here. It is in the same network. Look at here. What we have? We have data. And we have what? This is IP header. And this is data link frame. Data link, just that we just mentioned, the same as this one. The same as this one. This is IP, and the frame that I just deleted here. This is the frame. We're talking about this one and this one here. At this. Let's go back. Now what do we have? If we want to send a message from PC1 to the server, let's go to the IP header. What do we have? Source IP address. What's the source IP address? In the source IP address, the IP address have two parts, network and host. The network is 192.168.1, which is the same. The host is what? 110. This is 110. What about destination? Network. Is it the same? Yeah, the same. 192.168.1. This is 196.168.1. And this is what? 196.168.1. Why it is the same? Because they are in the same network. This is the same network. This is one network. So the network address is the same. Only different is what? Host. This is 9 for server. We have another one, Ethernet frame or MAC address. Source is what? A, blah, blah, blah. And destination is what? CCC. Okay, so we have it here. This is the message. This is the data. It's going to be like a message. The message is going to send to the switch. The switch is going to send it to what? Server. Nice and easy. مثل البريد بعنوان المرسل والمرسل إليه صح؟ Yeah. Look at here. It is we have a concept of something called Address Resolution Protocol or ARP. ARP, Address Resolution Protocol. What is ARP? ARP Every computer, see, every message, in order to send a message from one PC to another PC, what do we need? We need two addresses. One of them is IP address and the other is MAC. So usually, in case if this PC1 want to send a message to the FTP server, PC1 know the IP address of the FTP server, but it does not know the MAC. MAC is unknown. So what's going to happen? PC1 is going to send a message called ARP. Now in ARP, it is like PC1 is asking what is the MAC for 192.168.1.9. Where is this? Which is the server. So the switch will receive this message. The switch will send it to all its links. PC2 will receive it, FTP server will receive it, and the router will receive it. But who's going to respond? Only the server, because the server will notice that it's asking for his MAC address. So he will generate a new message, will say my MAC address is CCCC. Get it? Then this ARP reply, this is called ARP reply. ARP reply will reach to the destination PC1. Then PC1 will have the destination IP address and MAC address for FTP server. Then he will be able to send a message to it. Get it? Now, we have a concept of gateway. What is gateway? Default gateway. If you remember, let me set up a connection. Look at this. This is your internet connection. Let's say this is Ethernet. In the Ethernet, when we want to change the IP address, I think you all have seen this before. You go to the properties. What do we have here? We have IP address, subnet mask, and what? Default gateway. What is default gateway? Have you asked yourself before? What is default gateway? Default gateway is the following. Yeah, this is the default gateway. This is the default gateway. Here. It is the interface of your router to the internet. So this PC's default gateway, my default gateway is this. For this one, also this one. And for the server, the default gateway is what? If we compare it to this class, what the default gateway for this class? If you want to exit from this class, where is your default gateway? Yeah, this door, is that right? So this is your default gateway. It's the same as the internet. If you want to send a message to the internet, you must send it to someone who's be able to send it. And when you send a message, look at this example. Previous example that we discussed, PC1 was sending to this server from PC1 to within one network. How about if we send to server on the internet? Let's say this is internet. Let's say this is internet here. If PC1 want to send message to the web server here, what will be the source IP address? Source IP address will be the same as this one. 192.168.1.110, which is the same. Destination IP address will be what? 172.161.99, which is this one. 172.168.1.169. So this is address of the sender and address of the receiver, source. And what about MAC address? Look at her carefully. The source is what? A. Look at destination is what? Why we didn't put the MAC address for this one? Why we didn't put the MAC address of the server? I tell you what. It is the same as if you are at your home. You decide to go to Hong Kong. What are you going to do? You are at your home, sitting, enjoying, watching TV. Suddenly, you decide to go to Hong Kong. What you are going to do? You are going to take your BMW. Okay, again, you have BMW. And drive to the airport. Then from the airport, airplane will take you by several destinations until you reach Hong Kong. What is your default gateway in this case? Let me ask you this. What is your final destination address? It is Hong Kong. What is your source address? It is home. What is your next step address? Airport. Get it? Same concept that we have here. So, usually the data link or Ethernet frame, or sometimes we refer to it as MAC, it is next step address, while this one, the IP address, is final destination address. There is a movie, good movie, Final Destination. End of the chapter. So what we have studied in this chapter, we have studied the organization, standardization, all this stuff at the beginning. You need to Google it, try to search in the network about it. If you don't understand it, search about it. And we studied the network addressing, encapsulation, the default gateway, what is the MAC address, what is the IP address, in very simple way. Now, what I want you to do, please, use Packet Tracer, download the Packet Tracer, install it on your PC, do the labs in the Packet Tracer on your PC, because the lab time, 2 hours, is not enough. And read the chapter in Cisco Network Academy. You already have username and password now, you can log in. Open the chapter in Cisco Network Academy and read it. Go back to the notes that we take. The video recording is available on YouTube also about the chapter. Take the time to read about it, and probably you should sit while you have a Google. Whatever that you don't understand, just Google it. There is a lot of videos, wiki about it. So many things, resources on the internet about the chapter that we are studying. Okay? Any questions? Thank you very much, and see you in the tutorial.